Okay. All right. So here we go. Hopefully, I got the microphone ready. All right. Now I'm going to start going. So look up here. Look up here how I break this down. So I'm going to zoom in on this. And then what I need, let it go. It's frozen in class. Thank you. All right. And then, all right. So I'm going to take 176 off to the side real quick. 2 times, I think I'm remembering from last hour, it's 2 times 88. All right. And then 88 is 8 times 11. I'm going to stop right there. Everyone tell me what's 2 times 8. 3, 2, 1, go. 16. And then someone actually went ahead and told me what the square root of that was. But first, I want to break this down to make sense for everybody. This means, okay, again, 176 now is 16 times 11. You can go ahead and check that real quick. But my method of simplifying square roots, I want to find the biggest perfect square in the product. All right. So that's why I didn't keep treeing it out. I think it's the most efficient method. Now, everyone, what's the square root of 16? 3, 2, 1, go. So I don't understand why people have a problem with this. I'm going to be brutally honest. You reduce this down, first of all, to being structured mathematically. Those that are messy, I got some messy writers. Messy writers don't often do well in math because they don't keep their structures together. But also, it's kind of like keep everything separate, and you're kind of exercising PEMDAS. First thing I got to do is do something with this radical, and everything else has got to be left alone. Then next, okay, here we go. I'm gonna show something that you probably think is stupid, but I think this might be, according to first hour, the first time I've ever shown this. Are you ready? This is gonna come out of nowhere, maybe, but it has everything to do with what I'm gonna do next. Does 6/5 reduce? 3, 2, 1, go. No. Don't say I can change it to 1 1/5. That's just changing it to a mixed number. I wanted to make sure this is called an improper fraction. I'm going to do something nuts. Want to get nuts? Let's get nuts. Isn't 6 5 plus 1? First of all, yes or no? Yes. I made 6 a binomial, or I made it 2 terms. Okay, now, now the inclination might be let's take the 5s and cancel them. And then you're telling me that 6/5 equals 2. True or false? 3, 2, 1, go. There's no way that's true. 6/5 does not equal 2. So is my math valid, what I just did in that middle step? Yes or no? No. So why did I just cover that? Because even with me covering this right now, prove me wrong, 10 to 20% of you will do this in the future. You will cancel that 14 with this 18 and make that -7/8 there and ignore the 4. That from here on out, the rest of the year will be called a 6/5 equals 2 error. You are never, ever, ever supposed to take part of a sum and cancel it with something in the denominator like that. Or even if it was reversed, if I had a sum in the denominator and the numerator, I get people do this all the time. X over X plus 1. Oh, let's cancel the X's. Let's do that. That is awful. That is really, really, really bad math. Okay. And it can be reduced down to something simple like 6/5. So, what am I supposed to do? All right, this will be the last time that I write this because we're in honors. What you're really supposed to do is take out a 2 in the top. And then this becomes 2 root 11. And then you can cancel that free 2 with that 18 because it's part of a product now. So I can now simplify that. So why did I say that's the last time I'm going to show it like that? What you need to understand is these two terms, what do they have in common with the bottom? And it's a 2. And then in the future, I'm just going to divide everything by 2 and reduce that way. All right. So make sure you understand that. All right. And then I'll move on. Okay. First of all, what's the square root of a negative? 3, 2, 1, go. I'm pointing right here. What's the square root of a negative? 3, 2, 1, go. I. All right. And then 56. What is 56? I don't know. I can't think. 56, 2 times 25 is 50. 28. And then 28 is 4 times 7. Oh, that's my only perfect square. I can't. 4 times 2 is 8. Not a perfect square. So here's how I'm going to write this. 8 plus or minus. Let's get that square root of a negative out, and then we know that's an I. Get that square root of 4, and then I got to take that 7 times 2. That's a non-perfect square unit. Okay, so that's going to be the one stuck in jail. So this is how I stop my trees. I've identified the biggest perfect square in that product. Everything else is stuck. And then the next thing is, I'll show you right now how I quickly reduce this. Square root of 4 is 2. I like writing the I in the middle and then root 14 here. So again, I don't know what happens with structures. People move around the plus minus. I don't know. Again, this is math. Bless you. This is math structures we got to work on. I really hope I got my microphone working right. I'm going to be very mad. And then 6 over 5 equals 2. 6 over 5 equals 2 if you do that. But really what you should do is this. What do they all have in common? 2. Divide 8 by 2, divide 2 by 2, and divide 12 by 2. That's the quick, honors, fast way of doing this. Or this could be rewritten like this. This is legal, and this is actually a correct answer. You could split this up into 2 separate fractions. So I could do this, 8 over 12 plus or minus 2i root 12, or root 14, over 12, and then individually reduce these. 8 over 12 is actually 2 over 3, but then a big fat plus minus in between these 2 fractions. And then 2 over 12 is 1 over 6, I root 14 over 6. You could split these up into 2 separate fractions and reduce them separately. That will always be okay. All right. And if you're worried about the 6 over 5 equals 2 error, maybe go that route. But these are both valid answers. So either one suffices. If I could use a big fancy word. Okay, get ready for me to be annoying. All right, here is the quadratic formula. All right, and I'll do this first and then do the second thing. I reversed it in the other hour. Okay, I'll read along with you. You don't have to write this down. I wouldn't. All right. When you encounter a quadratic equation or function that is difficult to factor or unable to factor, you can always use the quadratic formula to determine the roots or zeros. Remember, the word root means zeros. It's one of the weird math words. For the quadratic equation in the form of, all right, I'm going to really zoom in on this. Ax squared plus bx plus c equals 0. That's standard form. I'm going to stop. We have not completed the square yet in this class. We haven't done a process called that. I know Mrs. Fasola's class, they did, before the last unit test. I'm waiting for when it really has a good purpose. But I'm covering this because the process of completing the square, which you may or may not have done in a previous class, if I complete the square on this, then this formula results. And I just want you to know that. Back in the day when I taught Algebra 2 honors, we used to go through that process. And maybe if there's like an off day where we're ahead of the other classes and I've taught completing the square, maybe I'll show you. All right, but at this point, you got to take a leap of faith that there is something that I can complete the square on this, and then this formula results. And then that's how you can get solutions to a polynomial. All right, and I'm going to tell you right now, there is no I don't get it. There is memorization. You need to memorize this. And if you have a problem with memorizing, then I have something to help you. Here we go. That's the wrong calendar. Are you ready? Oh, boy. Okay, here we go. This is great. Ready? Okay, here we go. You're going to love it. You feel free on verse 2 and 3 to sing along in 4. Oh, no! Oh, no, because I have this on. You can't hear it. Oh, I just ruined it because I'm making a tape of this. Okay, I got to stop the video. Hold on. This is ruined. The fun of this is ruined. So here we go. Where's my video? How do I stop my video? What's going on? What am I doing? All right.